Hello, Math 3 students. Mrs. Robinson here to work Practice Benchmark Chapter 2 with you. You can come here and get help. All right, let's go over the first one. Solve the equation. So this just goes back to your basic equation solving skills. First thing you want to do when you solve equations is simplify either side before you work both sides. So let's simplify with the parentheses here and distribute the negative to both terms. And this will give us negative y, and a negative and negative give a negative and a negative give a positive. That's hard to say. And then rewrite the left-hand side. All right, now both sides are simplified as much as I can, so now I'm going to start working both sides. Let's gather the y's together. I like to work with positive y's, so I'm going to go ahead and add 5y to this side. And that's going to give me negative 9 equals 5y minus y would be 4y's plus 1. I ran out of room, so I'm going to bring it up here. Negative 9 equals 4y plus 1. Now to solve for y, I'm going to peel off the 1 by subtracting 1 to both sides. That's going to give me negative 10 equals 4y. And then my last step, I have a multiplication here, so I'm going to divide to isolate the y. And my solution is going to be, and I'll write it up here, y is going to equal negative 10 over 4. If you'd like to put that into a mixed number, you can, or even a fraction. 4 goes into 10. What, 2 times with 2 left over? So negative 2.5. You can leave it like that. Either way is fine. All right, on to the next one. Let's do number 2. Okay, the good old 2 cars going in opposite directions. 2 cars leave Denver at the same time. So let's just draw a little picture. Here's Denver. They leave at the same time and they travel in opposite directions. So we'll do Denver here. And they travel in opposite direction. One car travels 10 miles per hour faster than the other car. So here's the guys going in opposite directions. The cars are 300 miles apart. So I'm going to write 300 miles after 3 hours. All right, so they were in Denver 300 miles apart after 3 hours. How fast is each car traveling? Fast is rate. So we want to know the rate of each car. What is the rate? Let's use our good old distance equals rate times time. So let's remember that formula. You should know that. Distance equals rate times time. So if you're driving to Denver at 60 miles per hour and you're driving for 3 hours, how far do you go? Let's go ahead and figure this out. We're going 2 different rates, so we need a variable for each, or one in terms of the other. So let's go car 1. Car 1 has a rate, car 1 rate. Let's let that be x. That's our rate. And then let's do car 2. Car 2 has a rate of 10 miles faster than car 1. So we're going to go, the car 2 would be x plus 10. Now the total distance is 300 miles per hour. Or excuse me, 300 miles, not per hour. That would be really fast. 300 miles. For 3 hours, how far did they go? Well, let's use our formula. Distance equals rate times time. We have car 1's rate and car 2's rate. So let's go ahead and figure out the distance for each car. Well, the distance for car 1 is going to be distance equals rate times time. So car 1's rate, which is x, times the 3 hours that they drove. Distance for car 2, that would be car 2's rate, which is x plus 10, times the 3 hours, the time that they drove, 3 hours. So that will be distance for car 2, and that will be distance for car 1. Now we know the total distance was 300 miles. So I'm going to add up the distance for car 1 plus the distance for car 2, and that will give me my total distance. So total distance is going to be distance of car 1 and then distance of car 2. I'm going to add their 2 distances together to get the total distance. Well, my total distance is 300 miles. The distance for car 1 will be car 1 rate times 3 hours, plus the distance for car 2 will be car 2's rate times 3 hours, x plus 10 times 3 hours. So we're just going to solve this for x, and then we'll get the rate for car 1 and the rate for car 2. X was car 1's rate, x plus 10 was car 2's rate. So let's solve this. Distribute here, we're going to get 3x plus 30 when you distribute 3 to each term. Then 3x plus 3x is going to be 6x, so we'll have 6x plus 30. And that simplifies all of this. And that equals 300. Now I need to solve to both sides. I'm going to subtract 30 to both sides. And 300 minus 30 is going to be 270. That equals, bring down the 6x. Last step, divide by 6 on both sides. And I'm going to get x equals 270 divided by 6 is 45, which will be miles per hour. There is my rate for car 1. Add 10, and car 2's rate will be 55 miles per hour. So that will be car 2's rate. So how fast is each traveling? Car 1 will be going 45 miles per hour, and car 2 will be going 55 miles per hour. And there's your solution. All right, on to the next one. Okay, the sometimes, always, never. All right, let's go ahead and look at this. Remember, there's a couple ways when we're solving equations. If you get x equals to a value, then you have just a solution. If you come up with something like this, and you solve all this and your x's fall out, and you get something like 3 equals 3, that's always true. This solution would actually be all real numbers, because it doesn't matter what I put in for x, 3 will always be equal to 3. But if I do this and my x's fall out and I come up with something like 3 equals 0, well, 3 never equals 0. So this would be never true. And the solution would be no solutions. Okay, that's a little symbol for no solutions. All right, let's go ahead and solve this. I'm going to solve for x. So on one side of the equation, I'm going to simplify anything I can. 7x's minus 4x's are 3x's. 3x's plus 7 equals 14 minus 7 is 7 plus 3x's. Okay, now I can already see on this side of the equation, I have the same exact thing I have on this side of the equation. You can simplify it even more. Let's go ahead and drop off the 3x's. Subtract 3x's from both sides. I'm going to have 7 equals 7. When is this true? It's always true. Okay, and your solution would be all real numbers. Any value for x is going to make that work. All right, on to number 4. Let's work this one out. Let's simplify this side of the equation first. 10x's minus 4x's are 6x's plus 11 equals, and on this side, if we simplify before we work both sides, 8 minus 10 would be negative 2 plus 6x. All right, I can see this isn't going to work because I have negative 2 plus 6x and I have positive 11 plus 6x. Those aren't going to be equal, but we can go ahead and keep working it. Let's subtract 6x to both sides to get our x's together. Well, they're going to fall out, and I'm going to end up with negative 2 equals 11. When does that happen? When is negative 2 equal to 11? Well, it's not. It's never equal to 11. Never true. And your solution would be no solution. Okay. All right, on to number 5. Let's solve each inequality. Then we got to graph the solution set. Don't forget this part. Okay. Solving this inequality. First, I want to isolate the r. Just remember this. Inequalities solve just like equations, with the exception of multiply or divide by a negative. If you multiply or divide by a negative value, you must flip the sign. Flip the inequality. So if it's this way, it would go this way, okay? And that's because on a number line, if you're heading this direction and you multiply by a negative, it flips your direction, all right? So let's go ahead and solve this just like we would normally. We'll just watch for that multiplication or division by a negative. Let's go ahead and add 9 to both sides. 2r is greater than or equal to negative 6 plus 9. Well, the 9 is bigger, so we're going to end up with positive 3. Last step, divide by 2. I am dividing, but I am not dividing by a negative, so I do not flip the sign. I'm going to end up with r is greater than or equal to 3/2. Now let's graph that. 3/2 is 1.5, so on a number line we'd have 0, 1, 2, 3, 4. So here's 1, 2, 3, 4. 1.5 is between 1 and 2. Now, because I have a greater than or equal to, I'm going to do a closed dot. It includes 1.5, and r is greater than, so it would go in this direction. All right, on to number 6. Okay, let's go ahead and work this one. First thing I want to do is get rid of that parentheses. So I'm going to go 2 times 3b is going to be 6b. And then 2 times 4 will be 8. And then this side will have 26 plus 6b again. And bring down that inequality. Now I can see a little bit of a problem here. When I pull my b's together, subtract 6b to both sides, your b's are going to fall out. And you're going to end up with 26 is greater than or equal to 8. Well, when is that true? Is 26 greater than or equal to 8? Yes, that's always true. 26 is always greater than or equal to 8. Well, how do I graph that? That's a strange question to graph. I don't have x as whatever. Well, since it's always true, to graph this, you would simply do a graph and you would just graph the whole number line. Everything works, everything is true. Done. All right, let's go on to number 7. Is the inequality sometimes, always, or never true? All right, let's work this one. First thing I want to do is get rid of the parentheses. So I'm going to go 2 times 10x, and I'm going to get 20x. And then 2 times negative 5 is negative 10 minus 9x less than or equal to 11x plus 13, da, da, da. Okay, combine your x's on one side before you work both sides. So 20x's minus 9x's are 11x's. So 11x's minus 10 is less than or equal to 11x plus 13. Once again, if I go ahead and combine my x's, they are going to fall out. There will be no more x's when I do that. And then I'm going to end up with negative 10 is less than or equal to 13. When is negative 10 less than or equal to 13? It always is. 13 is greater than negative 10. So this is always true. My solution would be all real numbers. So for this one, number 7, it doesn't ask us to graph, but if you were to graph, since the solution's all real numbers, you would just have a number line that covers everything. Okay, let's go on to number 8. Solve each compound inequality, then graph the solution. So now we got compounds, ors and ands. Ors usually are graphed apart, and ands are usually graphed together. Now there is a few exceptions. There could be ors that are on top of each other, but generally speaking, that's how we graph our ands and ors. So let's go ahead and solve each side. We have an or, so we're going to solve these individually. Let's do the left side first. We want to get x by itself, so we add 5 to both sides. We get 9x is less than negative 41 plus 5 will be negative 36. Or, and then let's go ahead and finish solving. Divide by 9. And x is going to be less than negative 4. Now I didn't divide by a negative. I divided by positive 9. So I don't change my sign there. Okay, I've solved that side. Let's solve this side. Subtract 13 to both sides. Bring it down. Hold on. And 7 minus 13 is negative 6. Divide by 3. on both sides, and you're going to get, I didn't divide by a negative, so I do not flip that sign. X is greater than or equal to -2. This is an or, so I have two solutions, this or this. Now to graph both solutions, I have -4 and -2, so I don't need to really worry about that side. -1, -2, -3, -4. All right, so there's my two spots. Let's go to this side first. I'm going to go to -4, and this is a less than. It's not less than or equal to. It's just a less than, so I have an open circle. It does not include -4. X is less than it, so I'm going to go in the negative direction, all those values less than -4. And then let's go to -2. Once again, open circle because it's greater than, it's not greater than or equal to. X is greater than -2, so it's going to go in this direction, and that's what your ORs usually look like. And that's number 8. Let's do number 9. This is a compound inequality, and this is an and inequality. I can tell because it's smushed together in the middle. Two ways to solve this. I could break this apart and do just this side and solve it, and then just do this side. So I would just do, oh, I don't have my thing going. I just do these two, and then I would come over here and solve this side of the inequality. Or I could do it all at once and get x by itself in the middle. And that's easier because then I just don't have to do it twice. So first thing I want to do is peel off the 4. I want x by itself in the middle, so I peel off the 4. If I add 4 in the middle, I have to add 4 to the right side and to the left side since I'm solving them all at the same time. It's like solving two inequalities at once. The 4 eliminates, and -10 plus 4 is going to be -6. Bring down the inequality. I didn't divide by a negative, so I keep the sign the same. Bring down the 2x. Bring down the inequality, and then 6 plus 4 is 10. Now my next step is to divide by 2. And if I do it in the middle, I do it to all 3 sides. And then that eliminates that, and I'm going to write it up here. -6 divided by 2 is -3. You got your inequality. The 2's go away, and I'm left with x in the middle. That was my job. And then I've got my inequality, and then 10 divided by 2 is 5. So I've solved this. This is an and inequality. Graphing it would look like this. 1, 2, 3, 4, 5. There's 5. -1, -2, there's -3, -4, -5. Okay, so I start at -3. I have a less than or equal to. It does include -3, so I do a closed dot. X is actually greater than -3, so I'm going to go in this direction. And that's how I'm going to go. And then I have a 5 over here. X is less than 5, not including 5. There's no equal sign under there. So I have an open circle, and x is less than, so I go in this direction. And my solution is where they cross over. So this will be my solution right here. From here to here. And you're done. Looking at number 10, what is the slope of a line that passes through the given point? So this should be reviewed from Math 1 or Algebra 1 if you took that. Slope. Slope is rise over run, or y2 minus y1 over x2 minus x1. Okay, subtract the y, subtract the x's. So if I subtract the y, if this is your x value, your y value, your x value, your y value. Subtract the y's, you're going to go -4 minus -10. You got a double negative, so careful with that. And then subtract the x's. If I started here with my y's, I start here with my x's. -12 minus 11. A double negative makes a positive. So -4 plus 10 is going to be +6. And then -12 minus -11, a double negative, that's going to be what? 22, 23. So -6 over 23 is the slope. That doesn't reduce anymore. That is rise 26, run back 23, or fall 6 to the right 23. When it's negative, you rise and go back, or you fall and go forward. All right. There you have it. That is a big slope. Let's look at number 11. Graph the equation. This is just your basic slope-intercept equation. To graph, I want to put in slope-intercept form. I could go ahead and do an XY chart like this and plug in 0 for X and then get out a value for Y. But I haven't solved for Y yet, for 1. And that's more work. Just use slope-intercept form. Okay, remember slope, y equals mx plus b. The value next to the x is the slope, and this is your y-intercept. Okay. This is what we did in Math 1 when we had all those arithmetic series, and then we worked into this. It's your basic slope-intercept form. So you got to put this in slope-intercept form. We want to solve for y. So to do that, we're going to take our equation, and we want to move this guy over here. So we add 5x over to this side, and then you get y equals, I'm going to write the 5x first, and then the -1 second. Now it tells me the number next to the x is my slope. That's my slope. So my slope is 5. My y-intercept is the constant, which would be -1. So my y-intercept, or my b value, is -1. Slope is always rise over run. Unless it's negative, you fall first. So we have 5, and we don't have a run, so we put it over 1. Start with your y-intercept. Remember, the vertical is your y, horizontal is your x. So I'm going to start with -1. That is my y-intercept. And my slope is 5, or 5 over 1. Start at your y-intercept and rise 5. 1, 2, 3, 4, 5, run 1. There it is. You can do it again. Rise 1, 2, 3, 4, 5, run 1. Or you can fall and go back. Fall 1, 2, 3, 4, 5, go back 1. And there you have it. Draw your line. Let me see if I can draw a line through here. No, that wasn't very good. Try again. We'll start here this time. No, try one more time. There we go. There's a line, and then I got arrows going because it goes on forever. All right, let's go on to number 12. Number 12, we want, I'm going to clear that off. The function f of x equals x squared. The graph of g of x is f of x translated to the left 6 units and down 5 units. What is the function rule for g of x? So if I take f of x and it's equal to x squared, that basic graph, I'm just going to sketch it. It's basically this. I'd like to translate it to the left 6 units and down 5 units, so it's over here, all right? So when I translate to the left, that is inside the parentheses. That's our x value. When we go inside the parentheses, it's always opposite the direction you think. So left 6 units would mean I add 6 units inside the parentheses, and then I square it. Down 5 units, well, down is the y value. Up and down is the y value, okay? I went down 5 units, so it's straightforward. I subtract 5. Just remember, left and right is opposite. Up and down is just straightforward, okay? So left 6 units mean I add 6. Down 5 units, I just subtract 5. And there's my g of x, and you're done. All right, that works for all functions. It works for x squared, it works for absolute value of x, it works for trig functions. When you guys get there, the translations work inside the parentheses with the x value is the opposite, and the y value is the straightforward value outside the parentheses. And you can try that by plugging in x and y values and see what happens. Or you can use Desmos.com and graph sum and see what happens. All right, what transformation changed the graph of f of x to the graph of g of x? So if your f of x was this, x squared, and your g of x is x plus 5 squared minus 9, what transformation happens? Remember, inside the parentheses is the opposite. So my transformation would mean I move left 5, and then I move down 9. And that's your transformation. It's transferring to the left 5 and down 9. How about this one? Same thing. Now we're doing the absolute value of x, but the same rules apply. Inside the parentheses is the opposite for your x values, left and right, and outside is straightforward. So we're looking at this. This would move. X plus 5 actually moves to the left 5 again, just like the last one. And then this moves us up 3. All right. Let's look at 15. Okay, what is the equation of the absolute value function? Okay, so remember your basic absolute value function is this. Y equals absolute value of x. Okay, your basic absolute value function, if I were to plug in values, you would plug in, I like to put my 0 here. If I plugged in 0 here, the absolute value of 0 is 0. If I plug in 1, the absolute value of 1 is just 1. If I plug in 2, the absolute value of 2 is just 2. Right? If I plug in -1, the absolute value of -1, absolute value turns everything positive because it represents distance from 0 on a number line, and distance is positive. So if I plug in -1, I get 1. If I plug in -2, I get 2. All right, so that's what it looks like for the absolute value. Hold on to that, and we're going to come back to that. Now I start at 0, 0, and then I have 1, 1, 2, 2. Okay, and here's what my absolute value looks like. Now it's shifted over here and it's flipped upside down. So how do I flip it? Well, I'm going to take my original function. Flip it means I got a negative out here. Okay, what that means is I take the absolute value of, let's say, 1. I plug it in, I get out 1, I multiply it by negative, and 1 becomes -1. So that flips everything downwards, right? That would flip everything downwards. Okay, so the flipping puts the negative there. But look, I've moved this way and down some, so I didn't just flip it. I moved to the left 8. So remember, the left motion goes inside the parentheses or the absolute value bars, and it's the opposite. I don't put -8, I put +8 in here. It's the opposite, okay? And so I'm going to go +8, and then I also moved it down to, let's see, -3. I moved it down 1, 2, 3. Now, vertical translation, straightforward, so I'm just going to go -3. So it flipped it. It moved it to the left 8 and down 3. Now, is it wider or skinnier than this? Well, how can I tell? Now, normally I go just up one value, 1, 1, 2, 2. So 1, 1, 2, 2. Is this fatter? Well, let's see. If it was a straight curve, if I plug in the first value, I would hit 1, 1 right here. Then I would go over 2, down 2. So if I didn't get wider or skinnier, my graph should be this fat. Whoops, it should be here. It should go 1, 1, 2, 2. It should be fatter, but it's skinnier, so I've stretched it. So instead of going to the first over 1 and down 1, which is what I normally do, I went over 1 and down. Where does it hit? Right at the axis, right here. I went over 1 and down 1, 2, 3, 4. So I had to multiply all these values by 4. So it should be a -4 out here. And that should be my equation. So I took my original values. I shifted it to the left 8, so I had to add 8. I shifted it down 3, so I subtracted 3. I flipped it, I flipped it upside down, so I had to do a minus. And instead of going 1, 1, 2, 2, it went over 1, down 1. That's what it should have done. It went over 1, down 4. So I had to multiply by 4 on the outside to make it skinnier. It stretches it. And that should be your absolute value. That should be your equation. All right. All right, number 16, graph each function or inequality. So we have an absolute value function. We know our basic absolute value function is one of these. So let's see what we're going to do here. Inside the parentheses, I didn't shift left or right. So my vertex doesn't move left or right, but it does move up 3. So I'm going to go up 1, 2, 3. Now this negative value here, this is going to flip my absolute value upside down. And this is going to stretch me by a value of 2. Now, what does that look like? Just double check it. Go ahead and plug in some values. Okay, so if I plug in a few values, and if I plug in 0, obviously, whoops. If I plug in 0, 0 times this is going to give me out 3. That's why I shift up 3. If I plug in 1, normally absolute value, I would get out 1 more up. The slope would be 1, 1. But if I plug in 1 here, 1 times negative 2 is negative 2. Negative 2 plus 3 is going to be 1. So if I plug in 1, I'm going to get out 1, which takes me down. And then I use symmetry. My axis of symmetry goes right through the vertex. I'm going to get the other side here. Now plug in 2. If I plug in 2, 2 times negative 2 is negative 4. Negative 4 plus 3 is going to give me, sorry, I'm being distracted by the children. What's negative 4 plus 3? Negative 1. I can do it. Over 2, down 1. And then symmetry, I do the same thing on the other side. So this is what my graph should look like. Now, if you didn't plot any points, you would note a graph like this because normally with an absolute value graph, your slope would be over 1, up 1, over 1, up 1, over 1, up 1. But when you multiply it by a multiplier of 2, you're going to go over 1, and because it's negative, instead of up, you go down. So you're going to go over 1, down 2, over 1, down 2, because now my slope is 2 instead, or here, negative 2. So it'd be negative 2 over 1. Normally, if this value isn't here, my slope would just be 1 over 1, all right? So just plot a few points. Another great thing to do is use Desmos.com. Just to check your graph. I'll pull that up, hold up. Okay, if you go to Desmos.com, this is a great grapher. You can just type in y equals 2, and I just use the little straight bar on my grapher. Oh, whoops, negative 2 times the absolute value of x, and then plus 3. And you can see when I push in plus 3, it shifts it up. So there it is, the absolute value of x. Plus 3 shifted it up 3. And that double checks our graph. Now, if you want to see what happens if I take away the negative 2, it flips it up. Now, if I take away the plus 3, it gives us our absolute value graph. So absolute value graph, if I add 3, it shifted it up 3. Okay. Let's look at our absolute value graph, and if I just multiply it by 2. So you can see here, the slope is over 1, up 1. Now, if I multiply it by 2, my slope should be over 1, up 2. So let's do that. And sure enough, it stretches it over 1, up 2. Now, with the negative, it will flip it down. So I still have the same slope, but it flips it down. Over 1, down 2. Okay. And then I shifted it up 3, plus 3. And there's that graph. So play with that for a bit. See how things work. All right, let's go on to 17. We need to graph this inequality. So in order to graph the inequality, you graph inequalities just like equations. You need to solve for y. So we need to put it in slope-intercept form. And I'm going to write it right up here. Negative 4x plus 4y is less than 4. So I'm going to get everything over, so slope-intercept form would look like this, y equals mx plus b. Okay. And that would be for an equation. For an inequality, it's the same form, except for we have an inequality sign. So we're going to add 4 to this side, add 4x, I'm sorry, add 4x to this side, and then we're going to have 4y is less than 4x plus 4. Now I need to solve this for y, so I'm going to divide both sides, the whole thing by 4, and I'm going to get y is less than, 4 divides into this by distributive property, 4 into 4 leaves 1, and I'm left with x. 4 into 4 again is 1, and I'm left with just 1. Now I'm in slope-intercept form. The value next to the x is my slope, and here that value, nothing is written, so the slope would be 1. The constant is my y-intercept, and that would be my constant, or my y-intercept would be also 1. Slope is rise over run, remember, so that's 1 over 1. And this would be my y-intercept. Let's put y-intercept. So remember, that's what b is, y-intercept. All right, so there's my slope and y-intercept. I graph this just like I would a line with 2 exceptions. The less than or equal to and the greater than or equal to sign tell me if y is less than, I shade down. So if y is less than, I shade down. If y is greater than, I would shade up. All right, so when you solve for y, it tells you which way to shade. If y is less than, you shade down below the line. If y is greater than. Now, if it's less than or equal to, I'm going to have a solid line. If it's just less than, I have a dotted line because it does not include the line. And the same for greater than or equal to. So first we put it slope-intercept form. We decide if it's solid or dotted, and we figure out if we're shading up or down. So in this case, we have our slope and our y-intercept. Y is less than, so we're going to shade down. And it is just less than, it's not less than or equal to, so it's going to be dotted. And now let's go ahead and do it. We start with our y-intercept of 1, so here's 1. And our slope is 1 over 1, so I rise 1, run 1. Rise, run, rise, run, rise, run. All right, and then since it's dotted, I'm not going to put a solid line. I'm just going to do a dotted line. And I know I kind of skipped the graph off a bit. Sorry about that. All right, it's not exactly accurate. I'm just using this weird mouse and it's hard to control, but it would be better if you did a straight edge on that. There's my dotted line, and then y is less than, so I'm going to shade down. So my shading is going to be all below this line. All right, all the way down to here, all the way down below this line. This is going to be my shading. It's so pretty. It's not pretty. All right, so that's what it should look like. Same thing for this. Let's first put it in slope-intercept form. So negative 3y is greater than or equal to 6x minus 3. Since we have an inequality that is a line, I am first just going to solve for y because that's how I get in slope-intercept form. Remember, y equals mx plus b. There's my slope and my y-intercept. I want y by itself, so I have to divide by 3. Red flag should go off. I'm not dividing by 3. I'm dividing by negative 3. I didn't say that right. Divide by negative 3. Ding, 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 red flags. I divided by a negative. I have to flip my sign. Don't forget that because your inequality will be totally off. When you divide by a negative, you have to flip the sign. All right, so I went ahead and divided by a negative. This sign is flipping. And over here, distributive property. Negative 3 into negative 6 makes negative 2x, and negative 3 into negative 3 makes positive 1. If you don't flip that sign, you're going to be shading the wrong direction. So my slope is negative 2. It's the value next to the x, or I put it as negative 2 over 1 because rise over run, and it's negative, so I'm going to fall over run. All right, and then my y-intercept is 1. There's my y-intercept. It's my constant. Slope and y-intercept. Now look at this. Y is less than, so I shade down. Y is actually less than or equal to, so it is a solid line. It includes this line. When it's less than or equal to, it includes the line. So I'm going to shade down a solid line. Let's go ahead and plot our y-intercept. It is here at 1. And our slope, negative 2 over 1. So I'm going to fall first instead of rise. So fall 2, run 1. Fall 2, run 1, fall 2, run 1. Or you could look at it this, you could rise 2, but then you have to go back 1. Did I count that right? Yeah, rise 2, you got to go back 1, okay? Since I have a solid line, I'm going to go ahead and make this guy solid. He's a solid line, and hopefully I'm hitting the right points there. I'm not going very accurate here. Okay, there's my solid line. And then here's my arrows. And then y is less than, so I shade down again. So my shading should be everything below, including the line, because it's a solid line. So all of this, if this extends, all of this is my solution. And you can make nicer shading than this. It's really hard to shade with the mouse, but that's what it looks like. All right, on to 19. Okay, so we have an inequality here that's an absolute value. Remember, the absolute value is this V shape. And it looks like if we had y, just to review this, if we had y equals to the absolute value of x, we would have the V shape at the origin. But I've taken that, if this were y equals to, it's not, it's an inequality, but if it were, it would be x minus 1, and then add 3. So I've taken my origin of 0, 0. I'm moving it, remember, inside is the opposite direction, so I'm moving it to the right 1, and then I'm moving it up 3. So my new vertex is going to be 1, 3. So instead of here at 0, 0, I'm going to move over 1, up 1, 2, 3. So I shift the graph that way. Now I don't have a value in front of here, so my slope is still going to be over 1, up 1, over 1, up 1, over 1, up 1. Now my axis of symmetry always goes right through that vertex, so I can do the same on the other side, over 1, up 1, over 1, up 1. I'm not stretching or shrinking any because there's no value in front of the x here to stretch me or shrink me. All right, so I took my origin, I moved it to the right 1, up 3, and there's my graph, so I'm going to go ahead and graph it. Now here I have y is greater than. Y is greater than this. Now careful, it's not greater than or equal to, just like the lines greater than or less than is a dotted. And then greater than or equal to and less than or equal to would be solid, meaning I'm including the lines, okay? So I just have a greater than, so I'm going to have to do a dotted graph here for my absolute value. And then y is greater than, since y is greater than or equal to, either of these, I shade up. If y was less than or equal to, I would shade down. So I want the y values that are greater than this absolute value, so I'm going to shade up. So it's going to be all of this. Once again, it's really hard to shade with the mouse. You could do it better with a colored pencil, but that's what it should look like. All right, we're going to solve the system of inequalities by graphing. So once again, the system is just like I'm going to graph this one and just see where their intersections are. And that's all I have to do. So this one, remember, I want slope-intercept form, y equals mx plus b, my slope and my y-intercept. So here, for this one, my slope is going to be -3, or -3 over 1. My y-intercept is, or b, is -1. And y is greater than, so I shade up. And y is greater than or equal to, so I have a solid line. Okay, everything I need to graph that one, let's go ahead and start with my y-intercept is at -1. No, I didn't do that. So that right here at -1. And then my slope is -3 over 1. So I'm going to fall first. Fall 3. 1, 2, 3 over 1. And I can do it again. Fall 3. 1, 2, 3, back 1. You can do it as many times as you need to try to get an accurate read. Or you could rise 3, but then you have to go back 1. So I fall 3 and go to the right 1, or I rise 3, 1, 2, 3, and I go back 1. Rise 3, back 1. Okay, it's a solid line, so I'm going to go ahead and try for that solid line right here. See if I can hit all the points with this guy. Trying as accurate as possible. Okay, and then I'm going to do my arrows because it goes on forever. So there's your first line, and then I want to shade up. So up would be this side. I know it's hard to tell because it's almost vertical, but up would be this side of the line. So I'm going to shade in red. Here's this part that I want to shade. Now let's go ahead and do the second line in blue. This is already in slope-intercept form, thank goodness. So I'm going to have my slope is 1/2, the value next to the x, and my y-intercept is 1. I have y is less than, so I'm going to shade down. And then y is less than or equal to, so it is also a solid line. So let's go ahead and mark it. We're going to go here at 1. There's my y-intercept. My slope is rise 1, run 2. Rise 1, run 2. Oops, sorry. Rise 1, run 2. I did it. It's hard to tell because I scribbled all of this. Rise 1, run 2. Rise. And let's go fall 1, back 2. You can go double negative, down and back. That also works, down and back. All right, it's also a solid line. Let's see if I can try to connect this through as accurately as I can possibly do here. All right, and then I want to shade it down because y is less than, so I'm here. Now the solution isn't all of this. My solution for this is where they intersect. So I'm going to go ahead and show you my solution, and I'm going to make it black. My solution would be this line and this line because they were solid. And then all of this here where the intersection is. This is my solution, all right, where the intersection is. And if you look at your answer key, that's what it should look like, that section. Oh, I just moved it. Yeah. Okay, on to 21. All right, I'm going to graph y is greater than or equal to 4. Remember, when I have y equals to 4, in slope-intercept form, y equals mx plus b, there's a slope and a y-intercept. There's no slope here. The slope was 0, so I just have y equals to 4. So where's y 4? Well, at 1, 2, 3, 4. It doesn't matter what x is. Y is always 4. X could be 1, y is 4. X could be 2, y is 4. So it's going to be this horizontal line, y equals to 4. But here I have y is greater than or equal to 4. Well, greater than means I shade up. And greater than or equal to means solid line. So solid line, and I shade up. So let's go ahead and make that solid line at y equals to 4, where y is 4 right here. And then I'm going to go ahead and shade up. And I'm in black, but let's go ahead and shade up in red, just in case I have to. No, come on, shade. There we go. Okay, so here is that first inequality. Let's do the second one. Y is greater than or equal to absolute value of x minus 1. Remember, your vertex is at 0, 0, and your absolute value has a slope of over 1 up 1. It's this v. Now, I'm going to take that v, and I'm going to move it. Inside, I go the opposite, so I'm going to move it to the right one. So instead of having an origin of 0, 0, or a vertex of 0, 0, I'm going to move it to the right one. So it's going to have a vertex of 1, 0. Move the x value to the right one. So I move it to the right one, and there is my vertex. That will be my axis of symmetry. There's no value in front of here to make it stretch or shrink, so I still go over 1, up 1, over 1, up 1, and the axis of symmetry do the same on the other side, over 1, up 1, over 1, up 1. And you can keep doing that until you get an accurate graph. And if you're not sure, I always say do this. Do x, y values. Plug them in. Start with 0. If I plug in 0, 0 minus 1 is negative 1. The absolute value of negative 1 is 1. So I should have plugged in 0 and got out 1. Plug in 1. If I plug in 1, 1 minus 1 is 0. The absolute value of 0 is 0. So if I plug in 1, I should have gotten out 0, and I did. Plug in 2. 2 minus 1 is 1. The absolute value of 1 is 1. When I plug in 2, I should get out 1, and I do. All right? So just plot some points and see what you get if you're not sure. Now, y is greater than, so I shade up. Okay. Y is greater than, it's not greater than or equal to. So it's just greater than. So it does not include this absolute value line. So it will be a dotted. It's not equal to. So I'm going to have a dotted graph here. This is going to be dotted all the way up. Dotted, dotted, dotted. Now I'm shading up, so I'm going to do it in blue, and it is dotted. It doesn't include the line. So here in blue is what I'm shading, but that is not my solution. My solution is where the two values intersect. So my solution would not include the line, the absolute value line, because it's dotted. It would include that black line that is solid, and my solution would be here in black where they cross over. right? So it looks something like that, just a section up there at the top. And it would just be here, this part, and up this way, and up this way in a dotted manner. Just this upside down triangle, but it's flat. It's flat. All right, there we go. Let's go to 22. All right, number 22. A group of 36 people attended a symphonic band concert. There were twice as many children as adults in the group. Write a system of equations that represents the number of adults and children who attend the concert. So a system of equations would be two equations, two variables here, because there are children and adults. So let's do this. There's twice as many children as adults, so let's start with adults. We can do A for adults. Let A equal the number of adults. And then we'll let C equal the number of children. Sorry for the writing, I know it's horrible. We know a group of 36 people attended. So we know the number of adults plus the number of children is going to be 36. Now let's write a second equation with what we have. There are twice as many children as adults. So then I'm going to say, well, the number of adults equals, well, let's do children, since there's twice as many children. The number of children equals 2 times the number of adults. There's my system of equations. I was just supposed to write the system. I didn't have to solve the system, but here's a system. Adults plus children is 36, and the children is twice the adults. Now to solve this system, I'm going to have to plug in 2a for c, use substitution. C is 2a, so plug this into here, and I'm going to get a plus the number of children is twice the number of adults equals 36. A plus 2 a's are 3 a's. 3 a's equals 36. Divide by 3. If I divide 3 into this, I'm going to get the number of adults is 12. Now I can figure out the number of children because I just plug this into either equation. It's easiest to plug it in here because it's going to tell me directly. The number of children is 2 times the number of adults. So 2 times 12, and the number of children is going to be 24. So children will equal 24, if you were to solve that. All right, let's go ahead and pause and scroll down. All right, we're going to solve this system right here. It doesn't tell us we have to solve by graphing or substitution or elimination. We get a pick. So looking at this and how these are set up, the 3x's and the 3x's line up nicely. I'm going to do this by by elimination. I can subtract this from this. So if I subtract this equation from the first equation, I'm going to do a minus the whole thing. So that becomes minus, this becomes plus, and this becomes plus. If I subtract, that eliminates the x's. Negative 5y's plus 1y would be negative 4y's. That equals 9 plus 3 would be. All right, let's go ahead and solve for y. Divide both sides by negative 4. And you're going to get y equals 12 divided by negative 4 is going to be negative 3. I've solved for y. Now I got to solve for x. I can plug into any of the originals. Let's just go ahead and plug in here for y. And it's going to be 3x minus 5 times y is negative 3 equals 9. Now I can solve for x. 3x and then negative 5 times negative 3 is going to be positive 15 equals 9. Go ahead and subtract 15 from both sides. 3x is going to equal negative 6. Divide by 3, and you're going to get x equals to negative 2. There's my solution. In ordered pair form, it would look like this. Negative 2, comma, negative 3. X, then y. Make sure you put those in the correct order. All right, let's look at 24. 24, I have 7x plus 2y equals 11, 4x minus 7y equals negative 10. The x's don't line up, the y's don't line up. I could use substitution, but that's going to be a pain. So my choice would be multiplication and then elimination. if I multiply, let's see, let's do the y's because they're smaller numbers. That's a 4 and that's a 2. So let's multiply both sides of the equation, number 1. Let's multiply and both sides of this equation by 7 because that will make this 14. And then we'll have to multiply both sides of the equation 2 by 2 because that will make that 14. And then these will fall out. So let's go ahead and rewrite equation 1 over here. 7 times 7 is 49x. 7 times 2 is 14y. And that equals 7 times 11, which is 77. And then do new equation 2 here. 2 times 4 is 8x. As long as you do it to both sides, you're keeping your balance. Minus 14y. And that equals 10 times negative 10, which would be negative 20. Now I can go ahead and use elimination by adding, and these are going to fall out. These fall out. 49x plus 8x, what is that? 57x. And then 77 minus 20 is going to be 57. So divide both sides by 57. That's a nice number. X is going to be 1. Now I found x. I can plug into any of the originals to get y. So, I don't know, plug into 1. We're going to go 7 times 1 plus 2y equals 11. So 7 plus 2y equals 11. Subtract 7 from both sides. 2y equals 7, 8, 9, and 4. Divide by 2. And then y is going to equal to 2. So you've got your x, your y, an ordered pair would look like this. 1 for x, 2 for y. There's your solution. All right, let's do the last one, which is a system of 3 equations and 3 variables. And let's go ahead and work that. When I'm working a system of 3 equations and 3 variables, the first thing I try to do is to see if I can use substitution to make it simpler. And it doesn't look like I have any substitution. Now, one thing you can do is you can use matrices. That's totally fine if you want to write out a matrix. 1, 3, 1, negative 6, 2, 1, 3, negative 4, negative 3, negative 1, negative 3, 6. And then you're going to get into reduced row echelon form where you have 1, 0, 0, 0, 1, 0, 0, 0, 1, and then your solutions will be over here. And you can do that by switching rows, multiplying one row by anything, adding 2 rows together. All the things that you really do when you solve systems of equations, you're just doing it in matrix form. It's like shorthand form for doing this. Totally fine. Okay, if you just want to straight up use our methods, this is how I do this. I label each of these, 1, 2, and 3. And you got to label them so you know what you want to do. So I'm going to look at these and I'm going to gather any 2 equations and eliminate one of the variables. Then I'm going to gather a different 2 equations and eliminate that same variable that I just eliminated. So let's look and see what might be easy to eliminate. If I added these 2 equations together, the z's will eliminate right away. And then I could add these 2 together and eliminate the z also if I multiplied this by 3. So I think the z's will be pretty easy to eliminate. Also the y's, if I added these 2, the y's would be eliminated easily. If I multiplied this by 3, these would eliminate. So either the z's or the y's, you get a pick. Now I'm going to pick the z's. So what I'm going to do is I'm going to pick any 2 equations. I'm going to pick equation 2 and 3 first. So equation 2 and 3, I'm going to write equation 2 and equation 3. I'm just going to work those to eliminate one of the variables. There's equation 2, and here's equation 3, negative 3x minus 3y minus 3z equals 6. Okay, now if I go ahead and add these together, the z's will fall out. Yay! Now I'm going to call this new equation 4, because I didn't have this equation. It's going to be my new equation 4. Add these together. 2x minus 3x is going to be negative x. Y minus 3y will be negative 2y. These fall out, and that will equal negative 4 plus 6 is going to be 2. So here's new equation 4, no z with it. Now I do it again with a different two equations. I used equation 2 and 3, so I can either use 1 and 3 or 1 and 2. Any two different equations. Let's do, let's see, what would be easiest? 1 and 3, because this is a negative and that's a positive. That will be easiest. So what I'm going to do is take equation 1 and equation 3 and add these two together to get new equation 5. The problem with equation 1 is it won't fall out with equation 3 right away unless I multiply equation 1 by 3 on both sides. Okay, so I'm going to write new equation 1 here. 3 times x is 3x. 3 times 3y will be plus 9y. 3 times z will be plus 3z. That's what I want because it will fall out with this. And then 3 times negative 6 will be negative 18. All right, so that's new equation 1. And equation 3, I'm just going to leave it alone because it has everything that I need it to have to make the z's fall out. So new equation 1 I wrote here, and equation 3 I wrote here. I'm going to add these guys together to get new equation 5. Add these together. Oh, look, there. Okay, I had to restart the recording because it clipped off this very last problem. And I'm just going to start it here. Okay, so I did equation 2 and 3. I picked those two, and I got the z's to fall out. So I need to pick a different two equations to get the z's to fall out, and I picked 1 and 3. I multiplied equation 1 by 3 so that I have 3z here. Now I'm going to go ahead and add. And look at this. When I add, the x's also fall out. That's kind of handy. That's going to make it so I don't have to do as much work here. So 9y minus 3y gives me 6y. And then the z's also fall out. And then this is going to equal negative 12. And then I'm going to divide both sides by 6. And that will give me y equals negative 2. Now, had the x's not fallen out, what I would have here is new equation 5 with the x and the y. And then I would take equation 4 and equation 5 over here and write them out and get one of the x's or either the x or the y to fall out so that I do end up with just one variable. So the whole point of doing these two equations and these two equations is to get one of the variables to fall out. So then I have equation 4 and 5, which are two equations and two variables. Get one of those to fall out, and then I've solved for the first variable. However, this made the x's fall out, so I've already solved for the first variable because the z's and the x's fell out. This made it easy, so I don't have to do equation 4 and 5 over here. So I have y equals to 2, or negative 2. Now I can come up in my new equation 4 up here, I can plug in negative 2 for y. So I'm going to do that, and I'm going to get negative x minus 2 times negative 2 equals 2. Go ahead and do the math here. Negative x, negative and negative makes positive 4 equals 2. Subtract 4 to both sides, and you're going to get negative x equals 2 minus 4 is negative 2. Divide by negative 1 or multiply by negative 1, it doesn't matter. X equals negative 2 divided by negative 1 is positive 2. So now I've got x and y. Now I need z. Now I can come up to any of the three of my originals and plug in x and y to solve for z. Just pick equation 1 maybe. Looks good. I'm going to plug in 2 for x. And I'm going to plug in negative 2 for y. So I'm going to have plus 3 times negative 2. And then plus z. And that's going to equal negative 6. And I just solve for z. So do the math. 3 times negative 2 is negative 6. And then negative 6 plus 2 would be negative 4. So this would be negative 4 plus z equals negative 6. That's supposed to be an equals. Go ahead and solve for z. Add 4 to both sides. And that will give me z equals negative 6 plus 4 is negative 2. So now I have x, y, and z. And I can write them as an ordered triplet, x, y, z. It would look like this. My x is 2, my y is negative 2, my z is negative 2. And there's your solutions. I hope this helps. Email me if you have any questions, and good luck on your benchmark.